Hello all. So today we are going to learn what is software engineering and why software engineering is important for an engineering graduate. So software engineering, it is a process of analyzing user needs and then designing, constructing and testing end user applications that will satisfy these needs through the use of software programming languages. It is an application of engineering principles to software development. So in contrast to simple programming, software engineering is used for larger and more complex software systems which are used as critical systems for businesses and organizations. So let's see about the formal definition of software engineering. Software engineering, so this is the definition given by IEEE. The application of systematic, disciplined, quantifiable approach to the development, operation and maintenance of software, and software engineering is relatively a new area of engineering, but the scope of software engineering is extremely broad, being one of the prominent branches of the field of engineering. It's growing among the fastest fields in the world today. And software development can be used for every type of software. It can be a simple one or it can be an advanced one. So who are software engineers? They are computer programming professionals. So software engineer is also a programmer and he also writes codes. And there must be a systematic process that leads to the understanding the requirements, working with terms and various professionals in order to create the application software. That's the work of a software engineer. So this software engineering is a program or it is a course that helps us to understand how the software must be developed, and it is a systematic approach that helps the software engineer to develop the software in a successful way. Software engineering is nothing but a systematic process which we use for development of our software. So you can see in this screen, this software is a collection of integrated programs and it is a carefully organized instruction and code written by developers, and we can use any type of computer languages for developing our software. And each software will have some computer programs and some related documentation such as requirements, design models and user manuals. So everything will be included into the software engineering. So we all know what is engineering. So it is the application of scientific and practical knowledge to invent, design, build, maintain and improve frameworks, process, etc. So if we are developing a software product, so these are the things you have to do continuously. So initially we will be starting with the analysis. We will be gathering all the requirements needed for the software, and then based on the requirements we will design the coding part using any one programming language that suits our software, and then we test the software using any type of testing. As you all know, we are having various type of testing. Based on the software we can choose any type of testing and we will be starting the testing phase of our software. And then deployment. In deployment, we will make our software ready for delivery. After delivery, if the software needs any updates, that can also be done by the team of software engineers. So updating and deployment is not only enough for developing a software, and we have to continuously maintain it. After that, we will be doing the final system design. So this is how the flow of development of software will be going on. So we can see one more definition for software engineering. So software engineering is an engineering branch related to the evaluation of software product using well-defined scientific principles, techniques and procedures. The result of software engineering is an effective and reliable software product. Now, let's take a look of what is a software mean. So software is instructions that when executed provide desired function and performance. Software is also a data structure that enable the programs to adequately manipulate information, and it is also a document that describes the operation and use of the programs. So when hardware is built, the human creative process, that is what we call analysis, design, construction and testing, it will be ultimately transformed into a physical form. For example, if we build a new computer, so initially we will be doing some basic drawings and then we will design a prototype. After that, it will be converted into a physical product. We won't directly start with the physical implementation. It will be very difficult to implement a product without a sketch. Initially, we have to sketch the basic steps, what are the things we needed, everything we will be doing, and then based on the sketch, we will start our prototype. So this is how we will create a hardware. Whereas software is a logical one rather than a physical one. In a hardware, we can build according to the sketch, whereas in software, we can't do it. Software is a logical one. Software is developed or engineered. It is not manufactured in the classical sense. If you are taking a physical product, you can manufacture it, whereas software will be a developing one and it will be engineered one, and it is a continuous process. Although there are some similarity exists between the software development and hardware manufacture, basically there are two things that is completely different. First one is high quality is achieved through a good design, but the manufacturing phase for hardware can introduce quality problems. But that will not be exist in the case of a software. Hardware, once it's built, if you want to start again, you have to rebuild it. Whereas in software, if we see that the software performance is not meeting the customer requirements, you can rebuild it. That is the easiest thing when we are considering a software. Both activities are dependent on people, but the relationship between people applied and work accomplished is entirely different. And another one, same thing, both activities require the construction of a product, but the approaches are different. So this is the first one, that is software is developed or engineered, it is not manufactured in the classical sense. And next one is software doesn't wear out. So this graph depicts the failure rate as a function of time for hardware. So in x-axis we have taken the time, and in y-axis we have taken the failure rate. The relationship is called this curve is called the bathtub curve. It indicates that hardware exhibits relatively high failure rates early in its life. So defects are corrected and failure rate drops to a steady state level. That's what it's represented here. So here it will be a steady rate one for some period of time. As time passes, that is as the value of x increases, the failure rate again rises and the hardware components will suffer from the effects of dust or some vibration, some temperature discomfort or many other environmental activities will lead to the failure of our hardware product. Stated simply, hardware begins to wear out, whereas software doesn't wear out, it only deteriorates. And the final point is, although the industry is moving towards component-based assembly, most software continues to be custom built. A software component must be designed and implemented so that we can reuse it in many different programs. There are many subroutine libraries that we can reuse in the array of engineering and scientific application. These subroutine libraries can be reused well-defined algorithms but had a limited domain of application. So this is what we see as a software engineering definition. So we were seeing it in the beginning of the class also. So this is the important diagram you have to draw after giving the definition for software engineering. So the first and the foremost bed layer for software engineering is quality focus, and then it is a process, and after that we are having methods, and finally we are including tools. So process, methods and tools. So we are saying software engineering is a layered technology and it is an engineering approach, and the main thing, the bedrock of any software engineering is the quality focus. So that is the main thing and basis thing in software engineering. So quality focus is the foremost important one in the case of software engineering. After focusing on the quality, process is defined. It is a framework that gives us a set of key process areas. These key process areas must be focused for effective delivery of software engineering technology. The key process tells what are the areas we have to concentrate and we have to spend more time in developing the software. And fine, next one is methods. It's a technical one and it tells us how to build a software. It includes an array of tasks and it includes requirement analysis, design, program, construction and testing. So everything will be included in the methods. And final one is tools. This is an automated one or it can be a semi-automated one, and it is used for supporting our process and methods. So these are the activities we use, and other than that, quality focus, that is process, methods and tools, we are using some umbrella activities